Hello students, welcome you all once again to Sri Chaitanya's NEET 10, the game changer program. So today, as a part of the sessions, we are going to discuss 50 slides in a session. That means class 8th and 9th we are going to cover up in 1 hour. Here the purpose of this session is that in 60 minutes, we should ensure that we attempt at least 50 questions. That's the task that you have for the coming examination. Alright, that means almost 1 minute is given to us to spend so that we can attempt the correct or get the correct answer. So this is a challenging task, we all know, and I thought let me club the two sessions and see how best we can get the answers like you have been giving the wonderful answers over the last 7 sessions. So I appreciate that. Now it is the time to solve the questions per minute. So I anticipate that you all are with me, and let's start the session with the question from the atomic structure. I think you might have seen that majority of the questions are usually from the atomic structure to start with, isn't it? Because it is very familiar chapter to us. So you can see it is simple question based on the theoretical aspect of the Bohr's theory, that which of the following is false regarding the Bohr's model. In all these questions, what would happen is that when you are solving the statement based question, they will consume time. So we have the elimination method or the identification method to get the answer to these questions. But these questions you can see that straight away based on the demerits of the Bohr's theory. The demerits of the Bohr's theory clearly says that Bohr's theory cannot explain the Stark effect and Zeeman effect. You know that Stark effect, that means when you place the spectrum of the hydrogen atom in the external electric field, each line is splitting into the fine lines. The same happens if you place that in the magnetic fields also. That's called Zeeman effect. You know, Stark and Zeeman effect are not explained, isn't it, Tilak? So you gave the answer, buddy. All right. It explains is the statement which is given. Rest of the statement looks to be all right. So you have to hit the bull's eye. Don't beat around the bush, particularly in case of the statement based questions. All right. So you please keep a stopwatch with you and stay tuned. You have to solve the questions within 1 minute time. Come on. Next question answer. Tilak. Speed up, buddy. Lithium, you should write the atomic number, isn't it? Electronic configuration. You can see that the maximum orbit number that we could achieve is nothing but the principal quantum number is 2. Indeed, looks to be 2 is there in almost all cases, isn't it? You got the answer. All right. Now you can see that n equal to 2 and L equal to is not possible is being said, right? N equal to 2 is possible, n equal to 1 is not possible, and also you can see L equal to what else is matching, buddy? N equal to 1 is there, n equal to 2 is there, and you can see L equal to, we have only s orbital with us, only 0 is there, right? So you can see that n equal to 2 is possible, L equal to 1 is not possible. You know that L equal to 1. Tilak, you made a mistake here, isn't it? All right, buddy. Got it? So 2 questions we discussed and 1 mistake you made. A hydrocarbon contains 90% of the carbon and 10% of the hydrogen. By what empirical formula is asked? Simple question, intermediate or NCERT based question. You know how to solve. Carbon and hydrogen's mass percentage is given 90 and 10. All right. You have to convert this into what? Relative number of atoms by dividing it with the atomic mass. When you simplify this, you will get 10 and this is 7.5, easy. Then you have to find out the simplest ratio by dividing it with the smallest value. Smallest is 7.5. You can see this value or the ratio is found to be 1:2. This value is how much? 4/3. So you can see that the empirical formula is C1H4/3 or C3H4. All right, buddies. Simple question, isn't it? Next, you see another stoichiometry question which is based on the simple principle, that is mole. You should always remember 1 mole is nothing but the atomic weight or molecular weight which is equal to 22.4 liter at STP and is nothing but the Avogadro number, that is 6 into 10 to the power 23. This Raghavendra, good afternoon, I am waiting for you. Right? So 14 grams of N2, that means how many mole? Half mole. Convert that into mole. For 6 into 10 power 23 is what you call mole of the N2. For this many molecule, it is 6.023 by 1.2044 mole. So I am writing here the mole of all the substances. 18 gram, that is 18 by 18, that is 1 mole. 9 into 10 power 23, that is 9 into 10 power 23 divided by 6.023 into 10 power 23. So you have to convert everything into mole, isn't it? Okay. So after converting that into moles, you have to convert that into the volume at STP. You know, half mole means 11.2 liter, isn't it? So you can see for A, what is matching is 4, isn't it, right? So you can see these two options are ruled out. You can work out on some other options, like you can see H2O, liquid, it's not liquid, it is the vapor which is given because you are measuring the volume of the gas at STP. So 18 gram, that is 1 mole, is nothing but 22.4 liters. So C is matching with 2, isn't it? Where is C matching with 2? What happened to this? 22.4 liters, 18 gram of H2O, C is matching with 2, isn't it? Alright, so looks to be C matching with 3, C 18, okay, because the point is H2O liquid might be taken. Yeah, this is another issue over here. Alright, so please understand that here taken is H2O liquid. So if it is 1 mole and if it is liquid, you see in the question you must observe carefully whether you are mentioned the gas or liquid. Since it is mentioned as liquid, you need to take the density of water as 1, and you know 18 gram means 18 ml. Yes, so this looks to be alright, buddy. So 18 ml, so C is matching with 3 and rest of the options can be mapped accordingly, right? So you can see the next question, A plus B giving rise to C plus D plus heat. That means this reaction minus delta H, because you can see that heat is released, exothermic reaction, right? Positive entropy change. That means the T delta S value is negative. That means this delta G value is negative at all temperature ranges, isn't it? Spontaneous at any temperature. Raghavendra, hope you are giving the answers and following up, isn't it? And you can see delta H of water is given as 40.7, entropy of vaporization. Remember, delta S of vaporization equal to Q, that is nothing but enthalpy change by at vaporization, the temperature is the boiling point. So you must write this as 40.7, alright, enthalpy of vaporization is this thing, and entropy is divided by 373. You please substitute and get your answer. Hope you understood, isn't it, right? So delta S is asked, delta H is given, boiling point of water is 100 degree, that is nothing but 373 Kelvin. Please substitute the value and get your answers. Alright, so you can see it should be in joule, it cannot be in kilojoule, right? Either this or that would be the right answer, that is okay. Next, we'll have the appreciable concentration of reactants and products. You see, always remember, if your Kc is high, when I say high, that means very high value, isn't it? Okay, Ram, Kc is very high. That means what? Concentration of product is very much greater than concentration of reactant. You can see what is the case here? 10 to the power 31. This is not 10031. This is 10 to the power 31. This is 10 to the power 8. So phenomenally high values of the equilibrium constant. That means the reaction has proceeded almost in the forward direction. So if the reaction has proceeded almost in the forward direction, there is more amount of the product which is formed, Tilak. So these two are proceeding maximum in the forward direction because Kc is high. And you can see this is 10 to the power minus 39. So Kc is very low. When Kc is very low, then you will say that the concentration of reactant is very much greater than concentration of product. However, when it is close to 1, that means concentration of product and reactants are almost equal. Alright, BF3 is non-polar because you know BF3 structure, the polarity of BF3 is cancelled because of the planarity that it has. So you can see the resultant of these two dipole is cancelling the dipole of this. So because this is having the planar geometry, though it is having the polar bonds, the compound is considered to be non-polar. However, when you look at PF3, because of the lone pair of electrons on the phosphorus, it is pyramidal in shape. If it is pyramidal, the dipole moment doesn't get cancelled, isn't it? You know that it is heading in this direction. So one could anticipate the dipole moment not to get cancelled, and you know that assertion is correct, reason is also correct, and also the assertion is the correct explanation of the reason. So the right answer should be A. Alright. Next, let's move on. Similar geometries. PCl3 you know is pyramidal. Let me write the geometry of all. So as ammonia. BeCl2 you know is linear. SnCl2 because of the lone pair of electrons on the tin, bent. Alright. Then what do we have? SiCl4 and CCl4 are tetrahedral. Alright. XeO4 is square planar. We have worked out all the examples in our previous sessions, and SF4 is seesaw. So you can see, yes, so you can see A and C are the only two sets of the compound which are having the same geometry. Rest of the geometries I have mentioned here, you please work out accordingly. Yes, brilliant, Ram, that's a brilliant answer. A and C, good. Statement is not true. Please understand here, whether you are asked true or not true, you should be careful, right? We are solving 1 minute per questions. So we should identify or trigger the right point to answer it. Not true. The conjugate base of H2PO4 minus is HPO4 minus 2. You know that when you remove the H plus, you will be getting the conjugate bases. That's absolutely correct. Next, pH plus POH is 14. Good evening, Raghavendra. Aqueous ammonium chloride is acidic due to cationic hydrolysis. You know that ammonium ion undergoes hydrolysis to give you ammonium hydroxide and H plus. So since H plus ions are produced, it is considered to be acidic. So you can see that A, B and D looks to be alright. However, you know that pH of any acid has to be less than 8. So this C looks to be incorrect. Oh my goodness. Check out your answers, buddies. When you are talking about a reactions, please ensure that you commit least mistakes, buddies. In the goose of attempting 1 minute, 1 questions, don't commit mistakes. We don't suggest that. Please see where mistakes are going. There are still 2 more days to go. Please be careful, be watchful. Anyways, you are not attempting what you call 180 out of 180. Okay, be careful. Even if you are attempting, please be careful. These questions are just idea based questions. Get the idea, put the answer. But the point is, you need to be careful while putting the answer. Please check twice before you mark your final answer. Please be careful. Yeah, what is happening here, that in a reaction, exponentially the concentration of the reactant decreases and that of product increases. That's all. You can see concentration of the reactant decreases. Alright, product increases, reactant decreases. That's all, right? So first and fourth should be the right answer. What do you say, Ramcharan? Another chemical kinetics question, buddies. You can see the rate of disappearance of hydrogen is given and rate of appearance of ammonia is asked. Listen now, how would you write the rate? Minus 1 by 3 dH2 by dt is equal to plus 1 by 2. You know that you have to inverse the stoichiometric coefficient to multiply the rates with respect to various components of a reaction. That's all. This is the equation, isn't it? Now you are given the rate of disappearance of hydrogen. So rate of appearance of ammonia would be, what's your answer buddies? dNH3 by dt is equal to 2/3 of T H2 by dt. You got your answer, isn't it? 6 into 10 to the power minus 3. Simple questions, right? Even MSET standard. Very good Ramcharan, brilliant. A solution obtained by dissolving 0.2 mole of urea in a liter of water, another solution by dissolving 0.4 mole of glucose. Both are non-electrolyte type, I equal to 1, Van't factor is 1. Remember this. The lowering of vapor pressure of the first solution will be, you know that lowering, not relative lowering. Delta P is equal to P naught, which is constant, into XB. That is NB by Na plus NB. Alright, this is the equation, right? For the first solution, you can see I'll write this as delta P1 and delta P2 for the second solution. Both are occurring in water only, equal to P naught into the number of moles of in another solution, right? So it is NB prime, I will call it as, divided by Na prime plus NB prime. Okay. Now you see a solution obtained by dissolving 0.2 mole of urea in a liter of water. So you can see relatively the amount of solvent is greater. So you can neglect this value. You can do that. Alright, isn't it? Now delta P1 is equal to, when you take the ratio, delta P1 divided by delta P2 is equal to your P naught get cancelled, isn't it? One value is given as 0.2 by what is left out is number of moles of A, which is nothing but 1 liter, that is 1000 gram by 18. I think you understood how I wrote this. By the other one is 0.4 mole, 1000 by 18. So this factor get cancelled anyways. So you can see that the answer would be half, that is delta P1 by P2 is turning out to be how much from the calculations? Is equal to 1 by 2. Alright. So that's all. Highest specific conductivity. Remember friends, specific conductivity depends upon the number of ions per unit volume. Alright. Can anyone guess what could be the right answer to that question? Arjun? I'm waiting for your answer, buddy. Can anyone guess this beautiful question, and can anyone tell me why? Arjun, Raghavendra, I'm waiting. Come on, buddies. Or you can try your best. You can see if you are going this by what you call the number of ions, you know that this and this have the same dissociation pattern, same number of ions. So you cannot mark both, right? The answer has to be among these two. You should know that the answer for such cases is this. I'll tell you the reason why. The concentration of pure solid is always taken as what? 1. That is maximum, which is constant. Maximum number of ions are present in that particular solution. That's brilliant. Brilliant, Arjun. I don't know what made you say that, but your answer is bang on. You can see that very popular question, frequently asked question, delta G naught, because this question combines second law of thermodynamics, electrochemistry and chemical equilibrium. So you know the equation, you know the relationship, right? So you can write this as what? E naught equal to 2.303 RT by F into log K divided by N. Why I am writing like this? Because you know this entire value as what? 0.059 by N into log K. You know that the value of E naught is given to us as 0.59. So this makes our calculation simple. That's the reason why I wrote it like that, and moreover, you know the value of what you call n. As you can see in this change, two positive charges are involved, so n is equal to 2. So you can easily simplify, isn't it? Now simplification becomes easy. Alright, so you can simplify this to get your answer. Next question please. Alpha D plus and beta D plus glucose, a pair of diastereomers. We have seen in the beginning of our sessions that these two alpha D plus and beta D plus are formed by the hemiacetal formation, isn't it? This is alpha, and when you write its counterpart, anomer, right? Alpha D plus and beta D plus are also called anomer. They are diastereomeric pairs. They differ in their configuration around the first chiral carbon atom after forming the hemiacetal structure. Alright, so it makes sense that they are diastereomer. They are also called as anomers. In our first session, we have discussed about the structures completely, and the rate of enzyme catalyzed hydrolysis of sucrose is faster than that of acid catalyzed reaction, because the purpose of using the enzyme, in this case it is called as invertase, because inversion of sucrose is taking place, is always faster because it's a catalyst, right, which is enhancing the reaction not only by initiating the reaction but also providing the platform for the reaction to take place. So enzyme has multiple roles to play here. That's the reason why it is faster. Okay, so Nessler reagent, you know that K2HgI4, straight question, plus KOH, when treated with ammonium, you will be getting HGO.HgNH2I, alright, which is a brown PPT iodide of millions base. In books it is also given as Milanose base. Doesn't make any difference, it is used for the estimation of ammonium ion, right? Lowest atomic radius. Dear students, you need to understand that chlorine has the covalent radius, because that it usually forms what? Covalent bonds. And the remaining, you can see that in all such cases, please identify the nature of the element which is mentioned, metallic radius. Now when you talk about the covalent radius, you know that due to the direct overlap of the orbital, the atomic radius is significantly reduced. Alright, good answer. Negative electron gain enthalpy, you know that electron gain enthalpy is inversely proportional to size. You can see among the elements which are given, they all belong to same group. Whichever is smaller has the more negative. More negative means it invites the electron very easily. Please don't get confused. Same will not happen with what you call fluorine and oxygen. You know that fluorine and oxygen have less negative electron gain enthalpy because inside there are more electrons. So they repel. Lithium does not repel because it is a metal, electropositive. Good answer. Can exist. Boron is very small. 6 fluorines around it, not possible. Nitrogen cannot form 5 valency because there are no 2d orbitals. Same is the case with carbon, small size. So only one thing which can afford it because of the large size, at the same time the presence of empty 3d, which will take the lone pairs from 3 fluorines to form dative bonds, 3 dative bonds. Good answer, brilliant. Arjun, give me the answer, buddy. Ramcharan, I'm waiting. Bhuwana, can you hear me, Rebecca, now? Sorry, I missed you out. Can you hear me, Rebecca, now? Am I audible now? Yeah, come on. Go ahead. Next. Fadafat. We have to solve 1 minute per questions, right? It's a task. It's a challenge. Arjun gave the answer, right? Come on, next question answer, please. I'm waiting. You see, we people generally interpret this to be a geometrical isomerism. Remember, when the two groups are same on the olefinic carbon that cannot show the geometrical isomerism. You gave A. That's what I was explaining you, isn't it, Bhuwana? What is the answer? This has only the chiral carbon atom, carbon with 4 different groups. So right answer is only optical, buddy. How can you give that answer? You see, A when treated with chlorine in presence of AlCl3, you know you will be getting benzene, right? A is obtained by the decarboxylation of sodium benzoate. First of all, you have to start from there. Sodium benzoate loses carbon dioxide to finally end up at benzene, and benzene when subjected to the chlorination, you will be getting chlorobenzene, methylation, toluene is the product, and finally nitration, nitrobenzene is the product, right? So this is D. You know that presence of electron releasing groups increases reactivity towards electrophiles. Among the 3 groups which we have, chlorine shows -I, negative induct, CH3 shows +I, NO2 shows -M. So we understood here more electron releasing, that is C, is more reactive than your normal benzene. Alright, am I right? Yes, because negative effect shouldn't be there, right? B, then you have last D. I think you guys have got it. What is leaving group? Chaitanya, beta, in which one? Mishra ji? What is leaving group? Okay, carbon dioxide, right? In which case you are asking, Chaitanya? Come on, go ahead, ask me which. So it is very hazardous for you to listen to these classes now. Okay, that's good. Glad that you are studying from class 8 for NEET examination. Not that much is required actually. Don't be in a haste. बहुत time है आपके लिए अभी तो. अब now listen, CH3, CH double bond, CH2 when react with H2O, you know that you will be getting what? CH3, CHOH, CH3. There is no scope of any rearrangement, normal Markovnikov product, right? Acid catalyzed hydration of alkene gives rise to the alcohol. The attack will take place on more substituted carbon, secondary in this case. However, when you carry out the hydroboration and hydroxylation, the product obtained would be anti-Markovnikov. OH will be added at the right side of that, right? Good. So what are these two? What are these two buddies? They are positional isomers. Looks to be all right. All right. One is 2-butanol. The other is 2 propanol, 1 propanol. X gives, what is X? They are positional isomers. X gives an aldehyde on oxidation with this. No, that's not true because it gives ketone. That's not true. Both X and Y gives haloform test. No, only this gives haloform reaction. Even that's not correct. CH3O C2H5 is the functional isomer of both. Yes, because this is having the same molecular formula of that and this is an ether, right? So looks to be that D is correct. Good. Prabhakaran made a mistake. The compound that reacts with the Grignard reagent to give methane, right? So you should know that any acidic hydrogen atom when present in the given compound, because the Grignard reagent is a strong base, it would abstract this proton. Any acidic in the sense sulfonic group, carboxylic group, phenolic group, acetylenic group, any acidic hydrogen atom when present. This takes the proton from that to convert into the alkane. Alright, this we study in the qualitative Zervetnov method to understand how many acidic hydrogen atoms are present in a given compound. So the whole, yes, I will discuss, Srinivas. We will discuss today all important topics. I am going to summarize everything. మొత్తం చెప్తాను ఒకటే 5-10 minutes. Please stay tuned until the end of the class. ప్రస్తుతానికి ఇది విందాం. Okay. Now we can see the negative charge is taking the proton. So wherever the acidic hydrogen atoms are, you can see this only has the acidic hydrogen atom. Remaining does not have any acidic hydrogen atom. Isn't it? Come on. Have you understood, Srinivas? Alkene treated with hot KMnO4. Hot KMnO4 always means oxidative cleavage. I suggest you to work out the answer like this. Listen, break the double bonds and keep the double bondos. You can see the products that are obtained. First you will get aldehydes or ketones, and later they will be oxidized further to give you the carboxylic acids. So you can see propanoic acid, CH3, CH2, COOH, and acetic acid, CH3, COH. First you will get an aldehyde which later converts into the carboxylic acid. You see, not the other compounds are giving. You see, this gives acetone and carbon dioxide plus water. This gives 2 moles of acetic acid. This gives acetic acid and carbon dioxide. So right answer should be B. Alright. Number of structural isomers possible. Always remember, when you are given a particular formula, structural they asked. With a hydrocarbon you can anticipate what? One is chain, the other one would be positional. This is what we could anticipate. What else do we get? With a hydrocarbon of the formula C7H16, which is an alkane, CnH2n plus 2. So in that case, what you need to do is always write the number of possible total structure isomers greater than the carbon number. This is a hint that I am providing. Are you following, Arjun? Number of isomers structural would be greater than the number of carbons. Blindly you can do that. It's a shortcut. So you can see there are 7 carbons, so answer would be greater than 7, right? Alright. That is the hint that I am providing. First, you can write otherwise. You can keep writing, right? You know, I'll write few structures if you want. 1, 2, 3, 4, 5, 6, 7, right? So you can keep the substitution. You have to work out on the structures by writing them at various positions. You can place it over here. So don't search for any formula here. It's a shortcut. The shortcut says that the number of structural isomers are always more than the number of carbon. So you can do it like that, right? Now you see incorrect match. Acidic nature in a group, remember, increases with size. So you got your answer right here itself, because the correct acidic strength order is this. Alright. Thermal stability increases with electronegativity. This is correct. Volatility, H2O, because of hydrogen bonding, the boiling point is high. Alright, boiling point and volatility are inversely proportional. You know, boiling point of H2O is greater because of hydrogen bonding. And after that, what comes into picture is molecular weight. Whichever has more molecular weight is less volatile. Volatile means getting evaporated. If the weight is more, it cannot get evaporated. Okay. Next question, please. Yeah, which of the following reaction is feasible? When you talk about the oxidizing power, fluorine takes electron easily. Fluorine, chlorine, bromine, iodine. When you talk about reducing power, it is opposite. Iodide is a better reducing agent. This is the order, isn't it? Now listen. So it is very easy for these two to react. Reverse, you can't do that, right? You know that fluorine is a strong oxidizing agent, so it will easily reduce the chloride, feasible. Bromine is not that strong oxidizing agent, and fluoride is not that good reducing agent, so you can't expect this. Next, Cl2 is a stronger oxidizing agent, and I minus is a good reducing agent, is feasible. Iodine is not a good oxidizing agent, however, bromide is a good reducing agent. This is not feasible. So looks to be A and C are only correct, isn't it? Ashok. Ashok, chemistry class is going on for NEET, buddy. You see that configuration, yeah, we have various options. You see, I'll tell you how do I proceed. Is 10 D10, right? First of all, this is stable electronic configuration. And when you're given certain what you call the atomic numbers, and when you want to understand, then in that case you should have the little knowledge about the atomic numbers. You guys please check the important instructions. In that page you will be given the atomic number, and you see the atomic number of what you call palladium is 46. When you write the electronic configuration of this palladium, you will write helium, neon, argon, krypton. All right. Okay. So up to krypton, the 36 electrons are being taken. 36 up to noble gas plus 10, 46, which is matching with what? Palladium. So go by the atomic number when you don't remember the electronic configuration. So atomic numbers would help you. Please read the important instructions well before you attempt the paper. Don't be in a haste. You see, correct reaction. All right. What is happening here? When HCl is removed, you will get a double bond over here. So CH2 is given. This is not correct, isn't it? This is a popular reaction, Rosen-Mund reduction. You are getting carboxylic acid. Not correct. You can see CO plus HCl gives CHO. This is what you call Gattermann-Koch reaction, isn't it? Very popular reaction, buddies. Koch. To prepare aldehyde, actually it is prepared from what you call phenols, but however this doesn't matter, right? If you want to do this, you have to use bromine in presence of OH minus Hoffman reaction. So this is also not correct. So only one thing which is matching is this. Yes, Rebecca, you are late, and today we are discussing 50 questions. Strongest base, you should know that where lone pair of nitrogen not in resonance. I am going to discuss 50 questions today. In 1 hour, I am going to teach you how to attempt. So, you know, when you are given the questions that the lone pairs are involved in resonance, isn't it? In all these cases, the lone pairs are involved in resonance except these two. Except these two. The lone pairs are not in resonance. Then in that case, sir, what should I do? In that case, remember, saturated nitrogen, the one which doesn't have any pi bond, is more basic. Saturated nitrogen, you can see this doesn't have any pi bond, it is saturated, happy, it can easily donate the lone pair. So the right answer is D. Delhi, Rebecca. Next, Wilkinson catalyst, right? It's also called as homogeneous catalyst because it brings everything in the same physical state. All right. So purpose of this homogeneous catalyst is, that is Wilkinson rhodium triphenyl phosphate chloride, is to convert what you call an alkyne into cis alkene. The same thing which Lindlar catalyst does. It is homogeneous because every substance in the same physical state. Heterogeneous is what you call hydrogen in presence of nickel, platinum, palladium. This is homogeneous. That is correct statement. Hydrogenation of alkyne as well as alkene, further reduction of this gives rise to an alkane. So it will reduce both alkyne as well as alkene. That's a correct statement. And statement 2 is lead poisoning. That's also correct. Yes. Okay. Next. Diborane will convert this into CH3, CH2OH. Next you have pyridinium chlorochromate will convert this into an aldehyde. And when you have got an aldehyde, you know, when you are writing the reaction with an alcohol, what you guys have to do is in the acidic medium, remove water, and you know you will be getting what? Hemiacetal and acetal. Finally, that is geminal diether is the product which is formed. Geminal diether. First hemiacetal and 2 moles is there, right? 1 mole give you hemiacetal, 2 moles will give you acetal. Which are the following acidic nature of the first compound is greater than that of second. You know the order, isn't it? Now let me write the order for you first. All right. Over here, you know, formic acid is more. Over here, what is given? The acidic nature of first compound is greater than, yes, this is the first compound is greater, since there is a very strong electron withdrawing group. CF3 must be greater, electron withdrawing group. Second is greater, electron withdrawing group. Second is greater. Only in this case, first is greater. Yes, brilliant. Always remember FBA, formic acid, benzoic acid, acetic acid. These three are frequently asked. In industrial process, nitrobenzene is reduced to aniline during tin and HCl or iron and HCl. That's a correct statement, right? We prepare aniline from nitrobenzene by reduction, right? By using zinc, tin or iron in HCl. FeCl2 formed due to the reaction of scrap iron and HCl gets hydrolyzed and whatever. So the point is, listen all of you, nitrobenzene is taken. When you take tin HCl, iron HCl, whatever, it would be converted into aminobenzene or aniline. This is what it says. However, in this reaction, iron is getting oxidized to FeCl2. Now the point is that FeCl2, whichever is produced, it is said that it undergo hydrolysis, it reacts with water to get HCl back into the reaction. So in a way that the product is not wasted, it is undergoing hydrolysis to give back HCl. So this is good for the reaction, isn't it? Both are true. Next, disproportionation is a fundamental question, Kavya. What is the answer for this? You should write the oxidation numbers we have seen previously also. +6 to +7 and +6 to +4 is disproportionation. Oxidation and same element got reduced. Cl2, 0 to -1 and same NaClO3, buddy. Same chlorine +5, I think, yes. Chlorine got reduced and chlorine got oxidized. So this is disproportionation, this is disproportionation. Phosphorus, we know popular reaction, -3 and same phosphorus +1. So phosphorus got reduced and phosphorus got oxidized, correct. However, here you see fluorine 0 to -1, here also -1, right? Because fluorine can't afford to have place oxidation state. We can't expect fluorine to be plus. Good answer. Solubility product, easy question, the molarity of its saturated solution, right? Solubility product constant of AgBr is given. Easy question, isn't it, right? AgBr dissociates into 1 minute, one question. Easy, I am explaining also. Solubility is S, so Ksp is nothing but S square. So S is nothing but your molarity, mole per liter. Don't think something else. What is asked is solubility. Priya gave the answer tens of times. She says 4, 3. Which one is your right answer? Then you tell me the right answer, isn't it? You can see, you can write this as what? Square root of, yes, 25 into 10 to the power minus 12. So 5 into 10 to the power minus 6 is the molarity. You got it right perfectly, all right, Priya. 3. Bond order. We know electrons increase, bond order decrease. Simple formula, right? So you have only 12 electrons. Here you have 18 electrons. Here you have 14 electrons. Simply you can do this, right? 14? No, 15. O2 plus, no. O2 plus 2, you got the answer here. O2 plus 2 is 14 electron system. 14 electron means what? Nitrogen, you know that, right? N2. You know bond order is 3, isn't it? For this, I believe bond order is 2.5 and this is N2 plus 1 is 13, right? Yeah. So 13 means the bond order is again, I believe it is 2.5 or something. You have to work out, and this is 1. So right answer is O2 plus 2. That's brilliant, Priya. O2 plus 2, yeah, thanks you. Thanks to you, Priya. 2.5, yes. The volume of water that must be added to a mixture of 1 minute, one question, right? So yeah, no, it's going to be easy, Grishu. We cannot predict exactly, it's a relative phenomena. You might feel one subject difficult than the other three. It could be chemistry, it could be physics usually. Grishu, so don't go with the prejudice that it's going to be tough. Alright, just stay calm, be peaceful. Whatever it is, it's not going to affect you badly unless your preparation was bad. So this is not the time to think. Anyways, you're going to taste the examination day after tomorrow. It's going to be easy then. For you, it's going to be easy. Believe me, Grishu. So have some confidence. You see the kind of questions. Please stick to NCERT. Please read your board books thoroughly. Please take one practice book. Solve all PYQs, previous year questions. Ask doubts frequently. Do the self-evaluation after the exam. That's all. The volume of water that must be added to a mixture of 250 ml of 6 molar HCl and 650 ml of 3 molar HCl to obtain 3 molar solution. We know that, right? Normality or molarity of resulting solution is M1V1 plus M2V2 divided by V1 plus V2. Listen to me carefully. Where can I find out? Oh, excellent. Good luck. So you got the answer, Priya? You're so crazy, right? You see the resulting solution is 3 molar. M1 is given 6 into 250. Alright, plus M2 is 3 into 650 divided by V1 plus V2 is 900. But you have added some water also, isn't it? Water will not impact the concentration of H plus thoroughly because it's a weak acid. However, it will impact the normality of the overall solution. So you need to write it as B, and she got the answer, both Rebecca and we can solve and get your answers, right? 250, that's brilliant. There is an important equation related to the degree of dissociation and vapor density. Please make a note if you have not studied this before. Alright, please make a note. Capital D is initial vapor density, okay, vapor density of N2O4, that is initially present in the equilibrium mixture, and small d is observed value at equilibrium, observed vapor density, and N is number of moles of the product formed from 1 mole of reactant. This is the data one should have to solve this question. So without wasting the time, let's substitute the values. Capital D is given to us 46 minus small d is given as 30 divided by N, number of moles of products, not delta N, friends, not delta N, only N, that is 2 minus 1 into small d is 30, and you are finding out in percentages, so you multiply this by 100, whatever. Good. Formula, you please make a note, pause, write the formula. Cytidine, it's a theoretical question. I believe the right answer for that question is double bondo. It's like on tautomerism, it will, as I remember, on tautomerism it gives rise to the aromatic species. That is the only one thing that I can tell you. You can see that it undergo enolization to give you the aromatic species. So according to that, C should be right answer. Let me check the key, because it goes like this. This is cytidine structure, if I am correct. Okay, so right answer should be C. Yes, all right. Please make a note. All right, oxidation number of nitrogen is least in +5, and when you find out this is +1 and each nitrogen is -1/3, -2, so nitrogen is +1 and this is -3. It's a basic question finding the oxidation number. Not N3H, Priya, you made a mistake. It is -1/3 and this is -3. So right answer should be, it's not in terms of what you call, is it No, -3. Lowest is asked. Least in the sense in the context of negative value, Priya. Ambedkar High School. If you are representing a school, obviously it's a competitor school, so I can't comment. As a student, you see any coaching institute or a school is secondary, right? How many of you know Ramakant Acharekar, who happens to be the first coach of Sir Sachin Tendulkar, isn't it? So we are the coaches, the entities are secondary, whereas your effort is primary. This I repeatedly say to all my students. It's your effort. We are there only as a torch bearers at the back of you. You are the one who will be running and taking in the front. So you need to be cautious in your preparations. Any school can be good if you are sincere and serious towards your efforts. Let's see. Conductivity, isn't it the factor that is dependent on number of ions? So you can see the ions of 4 potassium and 1 this whole complex species. So I is 5. Here the ions that are produced is 1 square bracket thing and this thing. This is 4 ions and this is 1. So conductivity is directly proportional to number of ions which are considered to be highest. This Priya got the answer. Brilliant. Rebecca got the answer. Raghavendra made a mistake. What is this? Non-terminal alkyne. First of all, CnH2n -2. Non-terminal 6 carbon atoms, alright. 1, 2, 3, 4, alright. 6. Non-terminal in the sense triple bond should be kept in the middle. I'm going to place over here. This is first example. Second example. But if I keep here, it will be the same, isn't it? Next one, you got the answer also, 3. Yeah, let me check the next one. You see how I should check is like, it should not be controversial at the same time. Like, if I place here, this is your third one. Isn't it, Raghavendra? That's all. Only 3 you would get. Yes, that's a brilliant answer, Priya. Yeah, phenol with zinc dust, you know that zinc will take away what you call the oxygen left behind the benzene. So A is benzene, and when chlorine is removed, the carbocation that is obtained is primary, CH3 CH2 CH2 plus, which will be rearranged to secondary, because secondary carbocation is relatively more stable. Now benzene is attacked by this secondary to give you cumene. Isopropyl benzene is commonly called as cumene. So what are A and B? Option C. 2023 PYQ. Looks that you are thoroughly following up the PYQs. Pretty sure that you will rock. You can see the next question is again statement based. Have some patience. Dichromate structures are equivalent and you have to pick the correct statement. Dichromate structure Cr2O7 -2. They can't be equivalent because the middle Cr3 plus 3. You see the middle one is different because it is bridged between the 2 chromiums. Rest of the 6 are equivalent because they undergo resonance. So 6 equivalent. Not all are equivalent. So it cannot be correct. Yes, this cannot be correct. This samarium is still hard. It's a theoretical question. And E naught value is very high, isn't it? Because you see what you should know that it can oxidize. Water means reduction potential of H2O. Reduction potential of H2O is plus 1.23 volt. Remember 123. Remember that way, it is not hydrogen, it is water. So reduction potential value of water is 123. So it is greater. This value is greater, you can see, than this. So it will reduce, or it will oxidize water. So it's correct statement. So C and D are correct. I believe B also may be correct. You have to assess that like that, because you see in the options you have C and D correct as this and this, and A is wrong. That means only one option left. That means MnO4. when you are stuck in this situation, I suggest you to do this. You know that Mn change slightly alkaline, right? Faintly alkaline. That means you should take here ammonia or H2O, in which manganese changes from +7 to +4, and iodine changes to what is given? Iodate. Maybe it is correct. Yes. According to the crystal field theory, configuration of d electron in iron +3, you know iron +3, the total number of electrons that are present are 5 in the valence shell, isn't it? And you can see that it's a strong field ligand. Therefore, the difference between T2G and EG, the delta naught value is very high. If the delta naught value is very high, you know that the pairing would take place and the configuration is, got it, Rebecca? C. Priya gave the answer C. Brilliant. Formaldehyde and formic acid, you see, interesting, many times asked. Formaldehyde has an aldehyde group. Formic acid also has an aldehyde group, but is because you see, if you look at the compound in that direction, you see there is an aldehyde group. So both will reduce tolerance, both will reduce failing. Lucas reagent cannot be used for both. Lucas is meant for alcohols. What is the answer? Sodium bicarbonate, because you know that it's a mild base which will react with only formic acid but not formaldehyde. You know that you will be getting HCONA plus CO2 effervescence. So right answer should be sodium bicarbonate. Made a mistake. Priya is correct. Williamson synthesis used for the preparation of, I told you that, what is Williamson synthesis? Sodium alkoxide attacking on alkyl halide. Ensure that this is primary. We know this. And one more thing, aryl halides and vinyl halides. What is that? Aryl and vinyl should not be taken, buddies. Should not be taken as the substrates because they have resonance. This does not go out because of partial double bond character. You can see, you break it, break the compound and check. Halogens, you cannot get. Halogens, 3 degree. Over here vinyl, can't take. 3 degree, can't take. Only aryl. You can see this you can take. Sir, how? Listen now. Very easy. This, that side you can't take, but you can take it the other side because this negative charge can attack on this, what you call benzylic halide, to give very much the Williamson ether synthesis product. I think you got the answer, Priya. Ashok, let's concentrate. Benzene diazonium chloride plus phenol is orange dye. You know the reaction, popular one. Popular one, isn't it? Remove the HCl, alright, and write the product. Orange dye is incorrect. You have to identify, buddies. This is correct. Electrophile is yes, because this is going to attack on whatever statement that you know first, you please filter that. After that, incorrect we will write. Then color of the product is due to the extended conjugation. What a brilliant statement, right? Extended conjugation will be obtained here, right? Extended conjugation is making it appeared colored. That's true. All right. So that's it. You got the answer. Right answer is B. Rebecca got it right. Priya, you made a mistake. Savdhani hati, durghatna ghati. As soon as you lose concentration, finished. Power of concentration. 2 days left. Only 2 days. Not even 2 days, isn't it? So between you becoming doctor and setting your life at a high standard and remaining confused, there is only hardly 1 day left. 1 day could bring many smiles in your face and lives. So as your parents, so I suggest you to concentrate, have some courage, confidence in yourself and in the teachers who taught you. Let there be no scope of any negative energy. Be very positive. We tried our best in helping you at the highest standards. I hope you guys have enjoyed it. Tomorrow I am going to discuss the important chapters. Okay, tomorrow anyways is the last day. So let me discuss now. If you are studying for NEET in physical chemistry, don't ignore structure of the atom, equilibrium, thermodynamics, right? Structure of the atom, equilibrium, thermodynamics. Organic chemistry, general organic chemistry, alkenes. You read thoroughly. Inorganic chemistry, periodic properties, chemical bonding. I can give you only 6 chapters during these last stages because from here maximum number of questions can be asked. And I don't want you to emphasize more, stress yourself more during the lag hours of your preparation. Stay calm, stay peaceful, sleep comfortably, eat light, talk less. Good luck, students. అయిపోయిందా?